Okay, good morning. Great to see you all here. And I think it's my second time in Cluj. And great city. It's great to be here back again. So, we're opening up Code Camp now, and I was thinking, like, what do I want to talk about with this? And I think it's something that's been on my mind for a while now, particularly as people are using AI tools a bit more. And it's really the issue of understandability. It's kind of, I noticed a while back, like my history is working with legacy code and helping people refactor and add tests and things. But it seems like the real issue quite often with any old code base is really the understandability. If you could understand the code well enough, then you can make changes effectively and everything works out okay. But so much code out there is just so hard to understand. Is this true? Hard to understand code, right? Yeah. And that seems like the problem behind the problem with legacy code. We can make arguments about, well, it's code that people have not been careful in, or things like this. But in general, complexity grows and grows and grows in systems. And as it does, we walk in and we don't have the history, and we try to understand what's going on, and we just fail over and over again in that understanding. And when we understand things only partially, then it's tough to make changes correctly. That's a tough situation. So with this, it's kind of going to dig a little bit deeper into understandability, what it is, and the things that we've attempted to do, up to this point in the industry with this. So yeah, what is it to be understandable, right? One of the things that's kind of interesting with this is that there's always this push to get people to write code that's more understandable, right? And you'll over and over again, you'll hear people talk about technical debt and good coding practice and good design practice. And the idea behind this is that if only the developers did the right thing, we would never have any understandability problems, right? Is this true? Yeah, it's a funny thing with this because that's a great dream, but I think that is this, it's almost economic in a way. It's kind of like when you have to make changes and sometimes you're relying on partial information, you grow things over time, and as they grow, they become much more complicated. And even the best code bases I see get into this space where you have some parts of the code that are pretty easy to understand and other parts that haven't been touched in years, for instance. And then nobody understands these parts of the code. And then there's this thing of like, well, when you need to make changes there, what are you really doing? What do you really know about this to make the changes well? And this doesn't stop us from making changes. We make our changes, but it might be that they are just like not quite right. And the complexity grows and grows and grows and grows, right? So it seems like trying to write better code is, the solution, but it's hard to do, and it always kind of fails a little bit. So, in the old days, what did we do about this? We said, yay, documentation. If everybody writes good documentation for their systems, everything will be okay, right? And we've kind of fallen away from doing that a bit because we recognize that as the systems are changing, keeping documentation up to date, it's very ridiculous. It's very hard to do this sort of thing. And economically, it costs too much to go and maintain accurate documentation going forward just on the hope that you might need it someday, right? So that's been an issue for us in the industry. So let's look at something a little bit different now, though. It's kind of like the thing that we tend to rely on now more than anything is really this thing of going and, just relying on team culture to go and actually sort of show, or allow us to go and convey information over time, right? And this is good when it works. How many people are working on a project now where the original programmers were doing the work? Yeah, it doesn't really happen very much, right? Most of us are walking into situations where everyone who started the project is gone. And then when that happens, you're like, oh, what do I do? You're looking through this mountain of artifacts, of scripts and code and stuff, and trying to understand enough to be able to make things better. In the ideal situation, the people who originally wrote the system, when new people come to the team, they explain things to them. And there's an overlap in time between the new people and the old people, enough to convey the knowledge about what's going on with the system. And this seems like a decent thing to do, but nobody really thinks too much about how this happens and whether it's, there's better ways of doing this, for instance. So I think one model that kind of helps with this, if we're going to rely upon culture to go and communicate understanding, is this concept of active knowledge. And what I mean by this is it's like a bit of a model, it's an abstraction. And you can imagine it this way. So you're looking at a graph here, okay? And this is like over time. And this might be for one particular part of your system. The height on that graph is how much knowledge there is in the organization about that piece you're working on. So let's imagine a scenario. There's a new feature request that comes in, and then basically you determine the areas of the system that you need to go and make changes in. And in one area of the system, there's very little that people know about this because they haven't worked in it in a long time. But as they're making the feature change, the amount of knowledge grows. How does the knowledge grow? Well, we learn things as we understand the system. And then it's great because, for a couple of weeks or months, we still know that information. We remember it, right? So the knowledge kind of grows in this area of the system, but then it starts to go and decay down on the other end. Why does this happen? Well, it decays because people start to forget, right? You move on to another feature and your mind is on that as opposed to the original thing you were working on here. And then maybe you leave the team or maybe you leave the organization. So for the organization as a whole, the amount of active knowledge about this particular area of the code just starts to go down over time like this. And it's interesting because you can look at any area of the system and see this kind of thing. You can say, okay, well, we're working in the area of the system, the active knowledge has been raised, and then it slowly decays, and then we do more work, and then it gets raised again, and it decays down. This makes sense? It's a good visualization to understand what happens in an organization. And, you'll be able to see these slides later online if you want, but there's qualities of active knowledge, right? It's kind of like when you interact with a system, that's when you're learning about things. And the more that you interact, the more active knowledge you have. And the knowledge fades over time, as I mentioned earlier. And the other thing about this is that the knowledge can go stale. And what does this mean? It's kind of like if you walk away from part of the system for a period of time, and people go ahead and change it, and you don't know about the changes, you have knowledge in your mind that is not the accurate stuff about the system now. You have old knowledge that is not really aligned with what's really going on with this system now. Another thing too is that this knowledge can be regenerated as you, easily if you go and keep the code clear and the design documentation that you have clear and stuff like this. When things are not very clear or understandable, it takes longer to go and build up active knowledge again. And the cool thing is that essentially if you basically do the work to find this knowledge or formulate this knowledge again, then it helps you make better decisions, and that's a good thing for us. So what does this really mean for us when we are doing our work? I mean, to me, this is all like a mental map of things. I can imagine different areas of the code and the level of active knowledge with all these different things. So it's funny about this because quite often in an organization, we think about managing people, right? Or we think about like the architecture of the system and what we want the architecture to be. But the thing about this, though, is to recognize is that this is probably the thing that we need to manage in a system. We need to make sure that we have enough active knowledge in the areas that we are concerned about, right? And we need to go and sort of figure out how to persist that over time. If we have an area with very low active knowledge and we need to make changes there, maybe we want to kind of like move some of our best people there for about a month to go and dig up things and understand things well enough to be able to go and make the changes that need to be made. And this is what we manage, right? So yeah, this mental model, maybe this helps, I think, for dealing with these things. Beyond this, I think there's a lot of other things that we can do. I put up this picture here. It's like, imagine it's kind of like, for your system, it's kind of like there's lots and lots of crazy stuff that's hard to understand. And you have to go underneath the surface to understand all the things that you have. There's this book that was written a long time ago called The Mikado Method. And I found this extremely valuable for going in sort of like trying to gather knowledge of a system I'm about to work in. A thing that we can do all the time is we can always look at the code and try to read it. But the thing that's tough is that when we're reading code, it's not like we're basically making a change at the same time. When you're thinking about making a change, you have to dig in and understand at a deeper level what's really going on in the system. What Mikado is about is this thing where you it's actually a code technique. And what you do is you kind of start with a particular goal. Like I want to go and add like a login, a capability to this particular application. And you ask yourself, okay, well, I have these various classes and I need to make changes here. I want to make the change to do this, and if I do it right now, can I do this? Can I add in this capability? And then you might discover like, no, I can't right now because I need to change this other thing, right? So you make note of that other thing you need to go and change, and then you go and look at that and say, okay, well, can I do this thing? And then you discover, oh yeah, I can do this thing. So you do this thing, and then you basically go back to do the top goal thing again, right? And the way that this works when you do this is when you're working in code, you go ahead and attempt to make the change, and when you run into an obstacle, you know what you do? You immediately revert back to where you were, right? And then you start again, and you basically are able to build up this tree graph of the things that you need to do to go and start to meet your goal, and then once you've gone all the way down, you basically solve the problems and you're able to go back up again, right? So this is a good way of going actually in the act of change, gathering more knowledge about the system, because you're going to learn the details when you're doing this kind of thing. Another thing I love to do is essentially characterization testing. And when I wrote the book on legacy code years ago, this is one of the things I really tried to outline. That, we often think about tests as a way of seeing the correctness of the system. But the thing about testing also is that there's this other way of using them. You can write tests to describe the behavior of the system. And the interesting thing about this is that this is acting like a detective in a way. So you have some part of the system you don't understand, and you say, in a test, you say, okay, if I do this and this and this and this and this, I get an answer back. Maybe the answer is equal to 0, right? And then it's kind of like you run that test, and if the answer is not 0, it fails, and then you go and find out what the actual value that was returned is, and you put that there instead of the 0, right? So you make a guess, and your guess is usually wrong, and then you find out the behavior that's really displayed there, and you make that the expectation in the test. And this seems like cheating in some way, because you're actually not, you don't know what the right answer is, you're just documenting what the software does. But this is a way of going and building up understanding. You start to really understand what the system is doing. And it's easy, because you are just asking questions and finding out the answers. And a great way of going and building up knowledge about things. So there's lots of things like this that we can do to go and start building up the understanding of systems. One of the things that I'm kind of fascinated by now is essentially how AI can help us with these problems. So has anybody ever seen this device before? You know what this is? Yay, it's an old school Kindle, right? But I love this thing that you can basically change the font size just by going and doing this on the screen. And it's like, font size is bigger or smaller. You know what I'd love to have? I'd love to have AI do the same thing with the meaning of text. What I mean by this is that kind of like you're looking at a giant scientific paper maybe, and then you basically choose to go and sort of like zoom out, and it gives you summaries at very high levels of it. When you zoom in, it gives you more detail in that particular area. And I think we can do this now, right? It's kind of like, here's the thing, give me a summary, deeper level, give me something which is a little bit less of a summary, but more like the real thing. At a deeper level, it's like the actual text, and then on any point we can go deeper and sort of get more detail about things. So it's like semantic scoping in a way, right? And it's funny about this because even though there's no device to do this now, right, or no dedicated software to do this now, I find myself doing this with AI all the time now and code. So an example of this, I call this lensing, is you can basically take some piece of code and you pull it into a chat window with AI. And this is for a giant class I use in, a software class I use in exercises while I'm training. And it's huge, just lots of crazy stuff in it. And I say, okay, what are the 7 most important responsibilities in this class? And it lists them out for me, right? And it's like, if I've never seen the code before, this is a great help, right? But then you can start doing this interesting thing. You say, okay, those are the 7 most important responsibilities. Why don't you actually go ahead and show me the 4 most important responsibilities? And the thing about this is that it's not like going and saying, of those 7, I'm picking 4. It's basically approaching things at a bit of a higher level, or lower, higher level when we're going down to 4. And this is funny because you know that with responsibilities in software, quite often you can have 2 and kind of see they're part of a bigger, more general responsibility. So much about seeing responsibility in systems is about the scope that you happen to be at, right? So we can adjust the scope in order to go and dig down and understand more about what's going on in the system. And LLMs are perfect for this because they are trained with semantic information, you know, all the shades of meaning of different words and stuff like this, right? So they can sort of look at an area of code and kind of like, it looks like it's about this based on all the code I've ever seen in the world. And this is great for us because what we can do is we can actually do things like, okay, now that we've identified this particular responsibility, please show me a sample extraction of a class that does that particular work. And you know, this is not perfect, right? Because we know that LLMs, AI, can have hallucinations. But for us to generate ideas and think about where we want to make our next moves with complicated systems, that's great. And even if we don't want to make those next moves right away, just to understand what's there, it's a powerful technique with this. Sound great? Hey, so AI is going to save our lives, right? Let's talk about the downsides in a minute or two. So I call this lensing. And I think it's an interesting thing about this because this is a process to gain understandability, but it doesn't give you the understandable result quite as easily. In a way, it's a bit of a hack. It's kind of like we can use this, just like if you have a vision problem, you can put on glasses and see near and see far away, but that doesn't make your vision better, it just basically allows you to compensate for bad vision, right? So we can use this to go and deal with code which is hard to understand, right? But it doesn't give us understandable code automatically. Anybody know who this is at all? Okay, this is Ward Cunningham, and he was basically a pioneer in the early agile methods. You've heard of wikis like Wikipedia and stuff like this. He kind of invented the idea of a wiki early on and made a wiki that was all about software design techniques and stuff. And it had a lot of very fascinating conversation, but a brilliant guy. And you know, I was talking to him one day over a decade ago, maybe 2 decades ago, right? And it was an interesting thing because he was a pioneer also in the Smalltalk programming language. Anybody know what this is at all, right? Okay, it's a very early object-oriented language, dynamically typed, had a very different syntax, but it was like wonderful because there were very few edge cases and everything was relatively easy to do. And many people felt like the future of the world as Smalltalk would be a great thing because it was so easy to program in. But there were, you know, for various reasons, it never really took off. But I was talking to him, and I said, you know, it must be wonderful to work in Smalltalk and stuff like this. And he says, you know, I actually think C++ is better in a way. I'm like, really? You know? And then I heard his explanation. He said, the interesting thing about C++ is that when you start to really mess up your design, compilation takes much, much longer than it would otherwise when you have bad dependencies and stuff like that. He said in Smalltalk, because there's no compilation, it's interpreted, you can go for a long time before realizing you have a mess because nothing tells you, right? And it's an interesting point of view with this, that essentially the limitations of C++ technology was actually able to give us feedback and show us where certain things were just not all that good. It became painful to make things too complicated, right? When it's too easy to do something, we can basically march along and create giant messes and not even realize how bad things are getting. Interesting dynamic, isn't it? That this thing can happen? And it's funny because I think that essentially this same kind of thing happens to us all the time, right? Think about like assembly language back in the day. Anybody ever written assembly language at all? Yeah, a little bit, right? And can you imagine writing any of our modern systems using only assembly language? Impossible, right? It's just too hard to do because there's no abstractions or anything, right? But when we developed high-level languages, it's good. We have the high-level languages and we can start to go and do things we could never even imagine before. But what else can we do? We can make messes we could not even imagine before, right? So there's this thing, and it's true, and even things as like powerful for us as automated testing. I remember talking to somebody once in the early days when we were trying to get people to go and do a lot of automated testing. And we were sitting in an audience as somebody was talking about a big project that people were working on. And they said back then that it's kind of funny because now that they had tests in place, they could easily make modifications of the system, even if they didn't understand fully what was there, because the tests would show us whether we changed any behavior in the system other than what we thought we were. And it was funny because once they had that working, all the business analysts would get upset because they didn't understand anymore what the system really did. The developers could make changes, but they couldn't get the big picture. And my friend next to me said, well, it's about time they don't understand. For years, we could never understand what they were saying, the business analysts, right? So, but it's this interesting thing that tests enabled higher levels of complexity than we'd ever really seen before in software development. Does this make tests bad? No. I love the tests, and it's great for the world that we can create much bigger software that's more complex than we've had before. But the downside to this is that seems like each new change that we introduce within development has the possibility of going in introducing more problems, and that's just the way life is with these things. So testing is like that. There's a classic paper in computer science called Reflections on Trusting Trust. And this is a wonderful read. It's back a long time ago. The couple of guys here are some of the early guys who designed Unix back in 60s and 70s and stuff like this. And one of them, Ken Thompson, who was actually involved in the development of the Go programming language, he's still alive. He wrote this paper, and it was really about this interesting thing of how you are able to go and change a compiler so that what it can do is basically introduce backdoors in the programs that it compiles. And then they illustrated a technique where you could do this and then actually set things up in such a way that all evidence of doing this is gone from the source code, but it perpetuates through the binaries. And it was really an interesting thing. And I heard that when this paper was presented, everybody's going back and looking at their compiler and trying to figure out if it had like this hack as part of it. And I remember reading the paper and saying to myself, okay, there's no such thing as security, right? Move on. I'm not going to go and deal with security because there are no solutions. It's just constant diligence to go and try to make sure things are systems are secure. So I don't like unsolvable problems very much. But it's interesting with this that sometimes you find a thing that shows you that something is not easily solvable, and you have to adjust your expectations. So the reason I think about this in this context is that I think that in a way we have a bit of an arms race when we're doing work to make things understandable. And it comes down to this. Essentially it's like as we are using AI, for instance, there's a report by GitClear, and it's worth going and looking up online. Look for GitClear code report, AI. And it basically points out that as we started using AI in the last year or so, there's much, much higher churn in public code bases. Okay, people are making more and more commits, and that's good, but the thing is they're actually changing the code that we've committed prior much faster. And the theory with this is that essentially it's like, well, most of these changes are really not refactoring, it's kind of like going and correcting stuff that was committed earlier. So it's easy to generate code and then maybe not know that it's really good, so you're introducing bugs and then you fix the bugs. So is this progress? Don't know. We can generate bugs faster than we ever did before, right? It's going to take time for us to go and actually figure out how to adjust practice so that we basically are able to go and maintain a good quality level with things as we use AI. But yeah, it's a case where you get the benefit, but you get a downside also when you're doing these things. It reminded me of an old thing I read a long time ago that was very interesting. It's something called the Peltzman effect. And this is something that back in the 1970s, some researchers had determined. And what they were doing is they were looking at the auto industry. And back in the early days, automobiles had very little safety mechanisms at all. But what they kind of discovered is that as they introduced airbags and seatbelts and all these other things, they kind of discovered that basically the number of accidents didn't really go down at all. But fatalities and accidents, had gone down. Like you hit more pedestrians, but even though people in cars don't die as often, right? And what they realized with this is that all the things that we do to make things safer, people take advantage of the safety and they take additional risk on top of it. It's kind of a strange thing, isn't it? Okay, you think that you add safety belts and airbags and stuff, and it's like, hey, okay, there won't be any more accidents. But then people feel, hey, I'm safe, I have an airbag in the car. And then they end up driving in a more risky way than they would have otherwise. That's kind of weird, isn't it? Yeah. And it's funny because part of you feels like, oh, wow, is there any progress at all? And of course there is. I mean, people are not dying in cars the way they were 30 years ago, for instance. But there is this effect where people compensate for the safety features that have been put in place to go and help them with things. And then, it's like, you can see the same dynamic here, like in skydiving. safer skydiving gear becomes, the more chances skydivers will take in order to keep the fatality rate constant. So this is a thing that's been recognized in many different areas. So we have tools that allow us to go and basically do much more than we could do before. But guess what? We're actually going to go and sort of like probably not have fewer bugs than we had previously, at least for a while, right? So we have to be aware of what's going to happen with that as we go forward. So the thing about this I think is interesting is that with artificial intelligence and all the advancements that we make in practice, it's interesting to look at this and go and say, well, do we make any progress at all? And I think we do. But I think the interesting thing to recognize is that there's this dynamic that we have with technology. And it's like, usually people want something and they will willing to pay money for it because it's hard to get. And then new technology comes along and it makes that easy to do, right? And then it's like, yay, all of our things that we want we can get from the technology we have here. And then you think, oh, okay, that's a permanent advantage, right? We now have solved a big problem, no problem. But here's the thing, people always want more, right? So then what do? We develop new technology to solve those problems, and yay, everything is good, except, guess what? People want more, right? So I think we're on at the beginning of an era when basically people are going to want far, far more complicated software than we're producing now, just because it's going to become a bit easier to write and a little bit easier for us to go and actually manage the complexity using tooling that we're developing now. And it's kind of scary in a way, I mean, it's great as a programmer if you're worried about losing your job to AI, because essentially it's just going to basically be the thing we're going to create bigger things that we have to maintain, I think, in a way. So it's just kind of I think the dynamic with this sort of thing. So I think the future is kind of interesting with this, and it's, the thing that seems kind of strange is that we want understandability, but we also introduce the things that kind of like get in the way of understandability. And you might look at this and go and say, is there any hope at all for this? And I think there is, right? The dynamic that we have within the industry, in software development, is that it generally is like whenever things become too complicated at one level, we introduce a level of abstraction above it, right? And I don't know how that's going to actually happen with like our AI tooling, for instance. But it's a possibility that essentially we start to go and develop ability to go and write code at a higher level and then basically use LLMs underneath or something like this. And hopefully not have to dig down into that lower level. And something like that's got to come along because people are going to try to solve their problems. And their problems are usually complexity, right? And how do we go and deal with it? So once we get to a certain threshold of complexity, we find ways to manage it and progress happens and we move along with things. But I didn't mean this to be like, hey, I'm predicting the future. But I think it's important for us to understand this dynamic. And that helps us go and gauge our expectations and think about where we can actually go ahead and advance things, perhaps through layering and abstraction. So that's really all I had to go and sort of like talk to you all about. And I don't know if we have time for questions or not, but regardless, I hope you enjoy the rest of the conference. So thank you.